Okay, so is there any question so far? Okay, I think then we'll get started. Uh, we are talking about some of the concepts that are beyond the basic, very basic concepts in SQL. And we talked about these outer joins and also about views. We'll talk about a few more such concepts in this chapter and in the next. So there is always a need, if you remember in the very first lecture and the following one, we said that if we have this database implementation vis-a-vis a file-based storage of data, there are several advantages that we get with database, and one of that is, of course, maintaining integrity of the data, and that would mean that there is something that we would be able to achieve if we use a database management system. And one of that is about integrity constraints, which is very easy to define in a database, and then the database management system will be able to enforce those constraints. So the advantage is that the enforcement part, as application programmers, we do not need to worry about. The DBMS will do it. All we need is to focus on deciding what are the constraints that we have to define for maintaining integrity. So that is what we are talking about now. So these constraints guard against accidental damage to the database, and it would ensure that authorized changes to the database do not result in any data inconsistency. For example, a checking account. So checking account is like what we call current account in India. Must have a balance greater than say $10,000. So that is a constraint that the business logic brings in. Okay. Similarly, the salary of a bank employee must be at least $4 an hour or something. So a customer must have a phone number. So what it means is that these are some of the constraints that are there in the business. So the business people know that these are our constraints, whether it is $10,000 or $15,000 or so on. The database designers will not know, but these are specified by the users. So, similar the ones we talked about. So, similar types of constraints can be specified, and these can be then enforced on the database by the database management system. So, let us take a look at some of the integrity constraints which are for a single relation. Okay. So, for that, we have the not null constraint, meaning that if we declare any column to be not null, then it will not allow us to enter any null values in that particular column. So, the DBMS will not allow us to enter any null value in that particular column. So, so as an example, if we see this previous page, what it says is that a customer must have a non-null phone number. So there should be a phone number mm, which cannot be null. So we can specify that in while defining any column in a table. Similarly, primary key we understand, and unique. So if you remember, there was a discussion about candidate key, super key, etc. So a table can have say more than one candidate keys, of which one will actually specify or identify as the primary key, but both the keys are equally good. That means that for any two rows, value of the keys will be unique. So if there is a candidate key on say roll number, another candidate key on say phone number for student table, so then or roll number and Aadhaar number, for example. So that would mean that roll number can also uniquely identify a row, and Aadhaar number also can uniquely identify a row. But so these two, both of these are individually they are candidate. But in a table we can only declare one of them as primary key. So suppose we define the roll number as the primary key. But then how do we ensure that the Aadhaar number does not repeat for two students? Okay, for two distinct students, the Aadhaar number also should be distinct. So we can do that by specifying that Aadhaar number column will be unique in that particular relation. So we can do that. Similarly, check P and where there is a predicate P which can be checked. So here is some example. So we can declare while having the SQL statement for create table, we can say that if say create table, say department or something where we have name and then budget, and we can say that these are not null. Similarly, unique, as we said, that the these attributes that is A1, A2, AM form a candidate key. I gave an example where there is a single attribute that is a candidate key, like Aadhaar number, but it could have been uh, a combination of attributes that forms a candidate key. So candidate keys are permitted to be null in contrast to primary key, but we can define them to be unique. Okay. And check P. So example is that it ensures that there are some predicates. Okay. So I just hide this. Okay. So suppose we have this semester in this section table, and the semester can take only these values. Okay. Fall, winter. Fall is like our autumn semester. Fall, winter, spring, summer. So assume that these are the possible semester. So if you say check semester in fall, winter, spring, summer, then when any row is entered in the section table, the value for the semester can be only one of these four. It cannot be anything else. And so that is what we can do by using this check constraint. So that was about integrity constraints on a single relation. And referential integrity means that we can say, as we have seen the example several times, that we have a student table where we have roll number, name, maybe date of birth, and so on. And also, we have the department code as one of the columns. And there is a department table which is department code and department name as its two columns. So what we want is that we want that this department code, whatever we enter in any row of the student table, that department code value must exist as a, as the value of a column in some row in the department table. So if I say that for a student roll number 1, name say ABC, department code is CS, then in the department table there must be a row where the department code is CS. If of course we define the department code column in the student table has a is related to the department code column of the mm, department table through referential integrity. Okay. Now, what happens is that yeah, the one way of defining it is that we say that this department code in the student table is a foreign key on the department code in the department table. So that is one way of doing it, like this biology, etc. example that is given. One point we have to remember, and this is very important, that is that uh, the so we have this referencing table. In this case, the referencing table is the student table, and the referenced table is the department table. Okay. So a requirement for foreign key is this, that in the reference table, like the department table, that department code must be the primary key. Okay, so that is important. Otherwise, you will not be able to define a foreign key from this department code on the student table to the department code on the department table. Of course, department code is not going to be a foreign key in the student table. So in the referencing table, definitely it is not required to be a primary key, but in the reference table, like the department table, it must be the primary key. Okay, so that is one thing. And one more point I will mention, which you keep in mind, because sometimes people ask this question. Say, remember we have this student and department entity relationship model where say students participation is not total. So that means that there might be some department codes which are null for some students. Say for roll number 2, the department code is null. So now, obviously that, but I want to define a foreign key from student to the department table. So that means that department code must be the primary key in the department table. And the primary key cannot contain any null value. So I cannot have any row with null for department code in the department table. But what I want is that in the student table, for some of the roll numbers, or that is some of the students, the department code is null. Remember that that is allowed. That means that even though there is a foreign key defined on the department code table from student to the department table, that means that if there is a non-null value, then it must exist in the department code column of the department table. So, but if there is a null value, there is no issue. So please keep that in mind. That is very important. Okay, and that's the reason I am actually going through some of these concepts, because these are otherwise easy to pick up as a language, but these are some of the subtleties that you may not know unless it is actually told to you. So it is allowed that we can have null values in the referencing table for that column. Okay. And of course, so once again, I'm repeating, by definition, because it will be a primary key in the reference table, it cannot take null values. Now, so there is something that we have to think, that say I have a create table this, okay. Now, say I have this again this we have this course table. So instead of student, we have course table, course ID, title, and the department name, which references the department table, okay. And then we have this. Uh, so there is another point we can mention, that on delete cascade, on update cascade. So these are additional definitions we can put. So what does it mean? It means, say in the department, in the course table, the department name, whatever is there, it must be uh, there in the department name column of the department table. Now what happens? We delete. Say there is this in the department table, there is an entry for the department CS. Okay, and then what we do is that we, in the course table, we have entered some course names for which the department name is CS. Now if we delete that row where the department name is CS from the department table, what will happen? These will be dangling now, because they do not have the references anymore in the reference table. So that cannot be allowed. Okay. So what are the options? So there are various options that SQL supports. One is that on delete cascade. Okay. That means that if the department name is deleted, CS is deleted, then all the rows in the course table for which the department name is CS, those also will be deleted. So if you write like this, then if you delete, then the database management system on its own will delete all the courses in the course table with that department name is CS. Okay. What if you update that department name in the department table from CS to say CSE? Then again in the course table, unless we update, there will be loss of referential integrity. So what you can do is that on update, you can cascade, means that you will update those CS values in the referencing table, that is the course table, from CS to CS. So that is what it means by on update cascade and on delete cascade. There are other options for delete and update, that you can do something. You can set it to null. That means if that in the referencing table, like the, say in the course table, the department name, suppose it allows null values. Okay. And currently for a row, the value is CS for the department name column in the course table for a certain row. And in the reference table, that is the department table, there is CS, everything is fine. But now you say delete that row where the department name is CS in the department table. Then another option is that you can set the value of all those rows for which the department name was CS in the course table to null. Okay. If it allows null values. Okay. The other is that you can also define for some of the, while you have the create table for any of the columns, you can say whether there is a default value. That means that if you do not enter any value, it will take that as the default value. So that makes sense more in the context of columns which are not null. If it is null, then if you do not enter any value for that column, the null value will be entered. But if we have a not null column in a table, then if you enter something without any value, so of course it cannot take null value, but it will take the default value. So what you can also do, like course ID char5 primary key not null with default CS, like that you can define in the course table. So that is independent of this concept of referential integrity. That is for defining the column type which are not null with some default values. Now, what you can do is that now when there is this update and there is a referential integrity, then when it is updated or deleted, you can have these options. On delete, instead of cascade, you could put set null. Then the value will be set to null, or on update, set null. And if it does not allow null, so of course you see that this will be a problem. So what you can say is that on delete set default, or on update set default. So that means that the default value will be set. If from ECE, suppose you update to something like say EC, and anything which is with EC, that may be set default to CS, like that. So you define depending on what you have set as the default value for that column. So these are various things that you can do. So that is about this integrity. Now, very quickly, we'll touch upon some of the built-in data types in SQL, which you are already familiar with. And uh, because you see, these databases are used for maintaining data for many commercial applications. And in commercial applications, it's very important that we keep track of date and time of certain things happening. For example, if you consider our ERP system also, this is very important that on which date who has sent some application, okay, say for micro specialization and something. So the dates are very important. Similarly, timestamp. So if you notice your registration card, the digitally signed registration cards, you will see that when the placard has digitally signed it, you get the date and time. So very often the date and time, which is called the timestamp, is very much required for such commercial applications or interval. So those things are very much important in SQL. So these are not to mention these are the only types. There are many such data types. This is just to give you some example about the time related data types. But some database management systems come up with their own such data types also. Okay, you keep that in mind. And and the important part is that these database management systems, what they do is that they provide you with a lot of functions for processing these date type, these date data types. Okay, like date, time, timestamp, interval. For example, we need say for any company, say we have the sales values for every date. Okay, now what I want is that say so sales value, say on 1st January, on 2nd January, on every day of the year we have the sales value. What we want is what is the total sales for the quarter, first quarter, which is for our country, this April, May, June. So instead of we have to write that, oh, I need to only consider the months of April, May, June for quarter one, and July, August, September for quarter two, and so on. So there are these built-in functions that can convert date to corresponding quarter, and then you can do group by on that. So these types of various functions are allowed. Okay, or sorry, not allowed, are supported by different database management systems. Or what is the say weekly sales? So it will accordingly convert the dates to weeks and club the sales and so on. So what I mean to say is that or between say two dates, how many days are there? Okay, so I have this date, say 10th February 2022, and say 13th December 2021. So there are functions like deaddiff and so on, which will give you the number of days between these. Okay, which are often very important. So these are supported, but one point we have to be careful that many of these functions, like on date type data, they are specific to the particular DBMS. And if you have developed your application using one particular DBMS, like say MySQL, and then later on you want to port it to Postgres, and if those functions are not supported there, then you will have difficulty. So then you will have to use the new functions which is supported in Postgres, or even there might not be any functions. We may have to write your own functions. So those are the things that are important. And as I said, that some of the date type data, some databases come up with their own data types. So if you use those, then you might have difficulty if you are porting your application to another database management system. But the take home point is that there is definitely a very rich collection of these date type functions in every database management system, which you can look at through their help menu. Next, we move on to, is there any question up to this? Let me take a pause and let me see, and then I will move on to the next topic. Okay, so if there is no question, let me move on to the final topic in this particular chapter, chapter 4 on intermediate SQL, which is about authorization. Now, this is something that we need to keep in mind. Uh, Say I have different tables in a database. Okay, I have a table, say student, department, course, and so on. Now, there can be many users of this database management system. And what we do not want is that we do not want every user to be able to access data, or every user to be able to update data in all such tables, because some of these might be sensitive. You want only some special people to be able to do that. So what is important is that we are trying to enforce what is called authorization on parts of the database. That means that we will decide that who can read maybe some data, but they cannot modify the data. Who can insert new data, but they cannot modify data. Who can update, but may not be able to delete. Some may be allowed to delete. Okay. So these are many different types of requirements we can have. And of course, we understand that read is like select in SQL, and insert, update, delete are also similarly insert, update, delete respectively in SQL. So we have the database management systems. They provide us with facilities for restricting access to various tables. That means whether users can select, insert, update, delete on various tables. And so this could be to also modify the database schema, whether any user can change anything, like we'll talk about indexes later, okay, that creation and deletion of indices on tables, okay, whether they can create new tables. One is that there are tables, the first four bullets, they show that for existing tables, whether certain users are allowed to select, insert, update, delete, but also whether certain users are allowed to create new tables, okay, whether they are allowed to alter, that means change the columns of an existing table, or they are allowed to drop the table. So there are different such possibilities that are related to modification of the database schema. And the first four are about accessing the data in various relations. So how is it done? So SQL supports this statement, which is called grant, and we'll see something called revoke. And it has got this generic syntax, but you can always look up on the net for very more detailed syntax. So this is showing at an abstract level what are to be included in this grant. So effectively, what it says is that you can uh, define like what you are trying to grant. Okay, that means select, insert, update, delete, etc. on either a relation name or a view name also. As we said that view can be used to restrict access, but once you have created the view, you may allow only certain users to use that view. Okay, and so the overall the statement has this form that grant and then what you are trying to grant, on means what relations or views, and then to whom you are trying to grant. Okay, so user list is the user ID, or you can say public means everybody can do it, which is similar to your chmod that you can do, or a role. So we'll cover about that very soon. So of course that the granting a privilege on a view does not imply granting any privilege on the underlying relations. Of course, whoever is granting must have the privilege on the underlying table. Otherwise, suppose I cannot access the table, so I cannot grant somebody else a view on that table, which is pretty obvious. So these are the more specific syntax. Like suppose we want to grant users U1, U2, U3 the select authorization on the instructor relation. So we write grant select on instructor to U1, U2, U3. That is that simple. Okay. Of course, we can, instead of select, we can make it insert, update, delete, or instead of writing grant insert, update, delete on instructor to U1, U2, U3, you can write grant all privileges on instructor to U1, U2, U3. So this is the basic concept actually, and as I said that you can always take a look at the exact details or the what all other parameters that can be used. Once you have granted, later on you may also revoke uh, that authorization. So you can do revoke privilege list on relation name or view name from user. So you can say revoke. So suppose I gave say grant select insert update delete on instructor to U1 U2 U3. Later on I want to revoke the select. So what I can do is that revoke select on instructor from U1 U2 U3. Then U1 U2 U3 will be left with insert update delete authorizations on that in this instructor table or the branch table and so on. And you can also do it revoke all on this from this. Okay, and revoke list also, instead of U1 U2 U3, you could also do revoke all on branch from public, so all users will lose the privilege. Okay, but that the last part is important, except those granted explicitly. So that is followed by the next bullet. See, suppose I have done, this is something you keep in mind, that suppose I did grant select on instructor to U1, U2, U3. Then also I said grant select on instructor to public. Okay. So then you see U1, U2, U3 got it from the first one, which was grant select on instructor to U1, U2, U3. Also grant select on instructor to public, they will get because of everybody is public, so they will be able to get it there also. But now if I do grant, I'm sorry, revoke select on instructor from public, okay, then whatever they were getting because of that public, that will be revoked. But this U1, U2, U3, because they got specifically also, so they will still retain that select on instructor. So everybody else, suppose there are 5 users, U1, U2, U3, U4, U5, and I did grant select on instructor to U1, U2, U3, and then grant select on instructor to public. So after I have done the first one, only U1, U2, U3 will be able to select. After we have done the second one, everybody will be able to select. But now if I do revoke select on instructor from public, okay, then that apparently you will feel that it will include U1, U2, U3, U4, U5 all, but it will actually do that. But because there is this separate privilege that was granted to U1, U2, U3 specifically, so they will still retain that permission to select on instructor relation, and U4, U5 will lose that. Even after that, if I do revoke select on instructor from U1, U2, U3, then they will also lose it. Similarly, after the two grants, if we first revoke from U1, U2, U3, like grant, revoke select on instructor from U1, U2, U3. So that specific authorization will be removed, but because of that other one which gave to public, even if you will still be able to do it unless we again revoke on instructor from public. So that is what it says. Okay. If the same privilege was granted twice to the same user by different grantees, the user may retain the privilege after the revocation. The other part is that, see here, what we are saying that we are talking about this user list means we have specific users that we need to mention here. But suppose there are, if we consider students, so there are thousands of students in our institute. So for someone to grant access to every student individually is very problematic. Okay, so for every student we have to right grant select on say registration table to every student, and because we do not want to give it to public, suppose we do not want the faculty to be able to do that. Okay, so now doing that individually is very very tiresome. Okay, and then when we have to revoke, a student has graduated, you will not have more access to the database, so then we have to revoke it from everybody. Okay, so which is not very convenient. So that's why this concept of role came into picture. What it says is that we can define a role called instructor or faculty, for example. So don't get confused with this instructor with the instructor table. And then this role is more like a role in an organization, a designation in an organization, like a teacher or a dean or HOD, director, and all. So it is very similar to that concept. And then once you have created a role called instructor, you can now grant this role to an individual user. So you see that it is nothing to do with a relation. It is just you are assigning instructor to Amit means that you are making making Amit a member of the role instructor. Now you can also grant privileges to roles. Like now you see that we can say grant select on text. Text is a relation to instructor. Now you see instructor is not a user. So we said here that we can do to this user list. This user list is, remember we said it could be a role also. Right? That's what we said, more on this later. So now we are discussing that I can say grant select on text to instructor. Now if you do that, then what happens is, because Amit is an instructor from that second statement, grant instructor to Amit. Now, if you give select on text relation to instructor, then Amit, being a member of the role instructor, will also be able to do select on that text relation. That is what it means. So roles can be granted to users as well as to other roles. Now, what we can do is that we can create a role teaching assistant, and that role teaching assistant can be given to instructor. So that would mean that it is like now you are building a hierarchy, that whatever these privileges now you assign to teaching assistant, anyone who is a member of the role instructor, because teaching assistant itself has been granted to instructor, so that user will be able to get all the privileges of teaching assistant also. And additionally, if you grant any other privileges to instructor only, so those also will be available to someone who is a member of the role instructor. So this is like a hierarchy that you can build. So it is like instructor is inheriting all privileges of teaching assistant. Okay. So yeah, yeah. Any question? So similarly, now in this process, you can create a chain of roles. Okay. So you can create like this dean role, and then instructor to dean means all privileges of instructor will be available with dean. And then you are giving dean to a particular person, say Satoshi. Then Satoshi will be getting all the privileges of instructor, and additionally all the privileges which are there with dean but not there with the instructor. Of course, that would mean that grant we have to give some grant select on some relations, or insert, update, delete, and so on. So it is not only for select, it can be also for others. Yeah, someone is asking a question. Is there any question up to this? Okay, I think So this is what is actually called role-based access control. Okay. So you might have seen that I have floated some projects on attribute-based access control. So that is this role-based access control has been there for quite some time, almost now 25 years. And recently there is this thing about attribute-based access control, new type of access control. So that is basically an area of research in my group. So we are also seeing whether or how we can bring in that notion of attribute-based access control in databases. But that is just to give you the perspective, nothing more than that. So similarly, authorization on views. So I create a view geo instructor as select star from instructor where department equal to geology, and we say grant geology on geo instructor to geo staff. So geo staff could be a role, and we have assigned that role to the users who are members of the geology department. Now, suppose that a geo staff member issues select star from geo instructor. Now, if mm, uh, geo staff does not have permission on instructor, so basically, if you remember that this view is about select star from geo instructor. So geo instructor being a view. So when we have select star from geo instructor, so it will try to get this thing from the underlying query. It will expand that view, that is select star from instructor where department equal to geology. So it will expand it. Now the issues that one has to keep in mind is that if this particular stuff does not have select permission on the instructor table, whether it will be allowed this permission from geo instructor, because in effect it will be uh, firing this query that it select star from instructor where department name equal to geology. And creator of a view did not have some permissions on the instructor. So whoever created the view, whether this will be allowed. So that is what we mentioned here, that if it is granting a privilege on a view does not imply granting any privileges on the underlying regulations. And the grantor of the privilege must already hold the privilege on the specified item. Otherwise, the grantor will not be able to give the access. So this is how this will be resolved. And different database management systems also handle these things in different ways. So you need to consult the respective user manual about how what is their way of interpreting the semantics of these types of authorizations on different views. But now, important point is that we have to keep in mind that views also can be accordingly used, like as you see that this grant select. So this itself could be a table or a view, which was also that was mentioned here. Okay, relation name or view name. So this is something that is important, because you would like to always restrict access to parts of the database to certain users only. And you may want some people to be able to select but not insert, update. Now, the other point is that references privilege. Now, this is something that is important. Okay, that is, let us understand this part a little bit. Suppose we have this whether you would allow, okay, somebody to define a foreign key. Okay, so let us take that example, that I have this student table where we have this department code, and the department table which also has the department code. Department code is a primary key in the department table. It is a foreign key in the student table. And this in the department, sorry, in the student table, say someone does not have a delete permission on the student table. Okay, so let us assume that that is there, but the that person has, say, delete permission in the department table. Okay, so like, and let me repeat. So the user has delete permission on the department table but not delete permission on the student table. And suppose I allow this person, this user, say you want to create a foreign key from that department table to the from the student table to the department table, and that is then that user uses the privilege to define that foreign key and with delete option, okay, on delete cascade option, for example, okay, on delete cascade. Now what this user can do is that user defines that foreign key on the student table to the department table, now goes and deletes a row in the department table or all rows in the department table which is authorized. So if it does, because of this on delete cascade, what will happen? The trigger will now delete all the corresponding rows which have the same value for the department code for the student table. And in this process, although this user was not allowed to delete anything from the student table, will be now able to delete by deleting something in the department table and causing that to fire the foreign key on delete cascade. So you see, so that is why that so first is this is the format for granting access to define foreign key. So grant reference on department name on department to someone. But this is also important because what you would like is that you would not allow everybody to create those foreign keys and then indirectly causing deletes of some rows in certain tables. So that's why we have this bullet. Why is this required? And I explained that otherwise this indirect way of deleting that path might exist, and you would definitely not like to do that. So initially you may want to revoke that foreign key creation permission from the public and then only selectively give it to those who you think will not do those kinds of things. Next is about transfer of privileges. So say I have grant select on department to Amit. So I give it to Amit, and if I write with grant option, that would mean that Amit in turn will be able to grant that select on department to other users or other roles. Okay. So similarly, if we revoke, I say revoke select on department from say Amit Satoshi cascade means that whomever Amit has given that select on department after the first statement. So Amit was given this authorization to select on department with grant. After that, Amit gave that select on department to say Priya, and now what I am doing is revoke select on department from Amit. Cascade means whatever Amit had given, say to Priya, that also will now be revoked. Okay. So similarly, instead of that, you could have restrict means that you are not going to let that happen. So that means that whomsoever Amit has passed it on, so those will not be blocked, but they further may not be able to pass on. So those various such combinations are possible in while defining this grant and revoke with grant option. So this is something very interesting. Like if you see that in your Linux, so if you create a file and you are the owner, and with chmod command you can give other somebody else a read permission, but that does not mean that that person can also again give read permission to somebody else. Okay, so you yourself will have to give that read permission to somebody else. Okay, but here what is allowed is that if you do it with grant option, so that means that Amit can again grant. It means that Amit, you actually trust Amit that Amit will only pass it on to others and not just give it to some people who might cause some damage. Okay, so that is like trusting Amit to do some things, and there are many ways that whether Amit also can further do it with grant or not. So there are many such possibilities that can happen. Okay, for transferring of privileges and revoking of this transfer of privileges and so on. So that's what I said that you read section 4.6 for more details about this authorization. It is very interesting topic, and you can actually do a lot of such fine-grained access control using these features. So these are the sections or subsections from the book chapter 4 that you need to focus on for this intermediate SQL. That brings us to the end of chapter 4. We'll next move on to chapter 5, but before that, we'll take a short break. Before we go for the break, is there any question from anybody? Barakula Dhanush Babu, you have any question? Maybe your microphone is not muted. Okay, so that is fine. So I will we'll take a break. So it is 10:53. So let us meet again at 11. Okay, I am stopping the sharing, and I am also stopping the recording for the time being.